Lesson 2.2, Video 1. Substitution is a method of solving a system of equations that's more exact than graphing. But to do so, we have to know exactly what it means. Now, it's a method of solving a system of equations in which one equation is solved for a variable, and then that equation is plugged into, and we would, instead calling that plugged into, we would call it substitution. That would be substituted into the second equation. So if we look at our steps here, which you have available to you, it says solve one equation for one variable. So if there's two variables in the equation, solve it for one of them. And some of these equations will already be solved for one variable, and that's a benefit. Then you're going to plug that into the other equation. Now again, plug into, we would say officially is we would substitute the expression from step one into the other one. That's a little more appropriate considering we're talking about substitution. And then we solve that equation. Once we get an answer, we'll substitute the value that we get from step 3 into either equation. It does not matter which equation you plug it back into, it'll be fine. So let's try one. Here we have an equation, a system of equations rather, where, as before it was mentioned, you have one equation that is already solved for a variable. It's solved for y, which means we will take what y is equal to and substitute into the second equation for y, which gives us 4x minus 2 times, now remember our y has been changed, or is going to be changed to negative 4x plus 20. And that is the substitution part that we're talking about. And then we have one equation now with all x's. So we're going to solve this for x's by, first of all, distributing, which gives us 4x, and then we get plus 8x, and then we get negative 40 equals 20. We solve this for x. These two are like terms, so we get 12x minus 40 equals 20. We will add 40 to both sides in the process of solving for x, which will give us 60. We'll then divide by 12 to undo the 12 times x, and we get x equals 5. Now remember, like when we graphed, we're looking for a coordinate. So the coordinate will have an x value and a y value. And we just found out that the x value is 5. So our last step is to find out the y value, in which we will take that 5 value and have a choice to plug into one of the two equations. Now here's where we want to be efficient. It is most efficient to plug it into this equation because it's already solved for y. We could plug it into the other equation, but it would just take more steps to solve. So we plug the 5 in for x, and we get y equals negative 4 times 5 plus 20. Negative 4 times 5 is negative 20. And now y is equal to 0. So our solution is the coordinate 5, 0. So if we were to graph it, we would have that point be where the two lines intersect. Solve the system by substitution. Now, if you look closely at this one, notice both equations are solved for y, but it's still the same process. We're going to take y for the first one and substitute in for the y in the second one, which gives us negative 3x plus 5 equals x minus 7. So we just replaced one of the y's with what it was equal to in the other equation. Now we have one equation with x, so we will solve this by combining like terms, which gives us negative 4x plus 5 equals a negative 7. We will subtract 5 from both sides, which will give us negative 4x equals a negative 12. Divide by negative 4 to undo the multiplication, and we get 3. Now remember, we're looking for a coordinate, and we just found the x value. So we'll take that, and we again can plug it into either equation. I'm just going to plug it into the top one, but both would be efficient in this case. Actually, the bottom one might be a little bit quicker. Let's do that instead. A little bit less steps involved there. 3 minus 7, I plugged a 3 in for x right there, and we get y equals a negative 4. So our coordinate is 3, negative 4. And this ends video 1.